Okay. Hello, and thank you very much for coming to this session about Istio and how you can start doing things like unicorns. First of all, well, this slide about sponsors. Thank you very much, because without the sponsors, this conference couldn't be possible. Well, I'm Álex Soto. I work in Red Hat, and I'm the curator of lotofthejars.com. I'm the author of Testing Java Microservices. Also, I've done some design ref cards, and currently I recorded a video course in open webinars. Well, I want to talk about Istio, but maybe first we need to do one step back to understand some of the basic concepts of Kubernetes. Probably most of you already knows, but I like to explain because I think that it's easier to understand Istio. Well, Kubernetes comes from the Greek verb helmsman, which is, the pilot of the ship. It's a container orchestrator. Probably all of us are using Docker in containers. So yeah, how you can scale up, down, and make these containers resilient. Then this Kubernetes supports multiple clouds. I mean, that works, I guess, that in all most popular clouds, and even in bare metal. In this case, I'm running on my machine. It's inspired by the Google's experience with containers. It's open source in Go. And one of the great things about Kubernetes is that you start managing applications and not machines. With Kubernetes, you don't care if the machines are in cluster A or cluster B or whatever. It doesn't matter. You have your application. You want 3 instances of your application, and then just Kubernetes takes care of managing this. This is a scheme of Kubernetes where we have the developer or the ops, and we have the master where you have the API, the etcd scheduler, and the controllers, and then we have several nodes. In each of these nodes, there is an agent or a daemon called kubelet, which is the responsible of getting all the work from the master and then just starting executing this work. For example, creating an instance of a Tomcat. And of course, this kubelet also takes care of checking the health of the container. If the container is behaving wrongly, then it just take care of shutting down and restart it. And then we have the nodes, and you can all the replications and so on and so forth. Nothing new, I guess. This slide, I think that it's quite important to understand Istio. And in fact, the most important things here is the first one, which is pod. And a pod, it's like an aggregation of several containers. Usually, people think that a pod it's just one container, because we usually we usually use it in that way. But a pod can contain more than one container. In the next slide, you will see why. And for example, it shares the IP, the storage, the resources, and even the life cycle. So if one of the container that is inside the pod dies, the other container as well dies. And then we have this replica control and deployment, which is that ensures that if you said that you want 2 instances of your application, ensures that there's always 2 instances running. Then we have the service, which is like a way to group pods, because at the end, if you have 3 instances of your application, you have 3 pods, and you need a way to address globally these pods, because in pods, the IP is dynamically assigned, and in the services, it's something that is just static, and even it provides you a name. So it's the way you have to access to your service. And finally, we have the labels, which is like a key values aggregation that you can add it in any of the Kubernetes resource, and you can do things like, for example, amp equal production, and then you can address the traffic, saying something like, I want to send my traffic to amp production, and then just Kubernetes checks these labels and address the traffic. And this is just a curiosity, and this is why pods can have more than one container. And the answer is that because pods, it's an English word, which it means a group of whales, right? So in Docker, there's whales, right? I mean that the logo is a whale, and you can understand that a container is a whale, then a pod is a group of whales. So for this reason, in Kubernetes, a pod is a pod and can contain more than one container. So why Kubernetes is really popular? Probably it's because of microservices. And you can think about that. This is how we can summarize a microservice, just one, which is like my service that can be implemented with any language. I mean that Vertex, JavaScript, Spring Boot or whatever. But each microservice because it's a microservice and it's like, distributed computing comes with some cross-cutting concerns. These concerns are discovery. You need to know how to discover the services. API, you need to define a public API to know exactly how to access it. You know an invocation, how you invoke it, if it's HTTP, gRPC, or whatever, that you need to know how to invoke it. There is an elasticity. What's happening if I have, I need to scale up because I'm having a big amount of traffic, or I need to scale down. Also, I need that my services need resilience. If I have service A that needs to communicate with service B, and what's happening if the service B is down? What's happening if the network is down? This is something that with monolith we didn't have this problem at all, but now in microservices happens. Then there is also a pipeline. You need to define a common pipeline on how to build, deploy, and release your service. Authentication as well is quite important because now we have several services that are communicating, how we authenticate between them to know that all the communication is valid. There is the logging. Usually monolith, we have like a big file, right, where there is all the log messages. But now in microservices, all your services are distributed across the cluster, and then you don't have the, the big picture of all the logs. So you need a way to aggregate all logs. We have the monitoring, knowing what's happening inside your architecture, and finally, tracing, which tracing is something quite new because of microservices, which is like what's happening with the request and response inside my cluster. Because we have several services we need to know. I've received a request in service A. The service A has communicated with service B, B to C, and between A and B has stayed there like, 3 seconds or 4 seconds or whatever, right? So we need all these cross-cutting concerns there. And the thing is that how we can deploy this, right? And of course, with Kubernetes, it's really easy to deploy it. But at the same time, as I said, all the services are interconnected between them. So there is the network there. And I like this quote of Christian Posta that say, as we move to service architecture, we push the complexity to the space between our services. So now, our services should only contain business logic. But what's happening is that since we have some network communication, we have moved there the complexity. And then we end up with something like this. If we are using Kubernetes, we fix the monitoring, discovery, invocation, and elasticity, more or less. If we move forward and we use, for example, OpenShift, then OpenShift is like Kubernetes for enterprises, and we also are fixing the problem of logging and pipeline, right? But we still have some problems with, for example, authentication, tracing, and resilience. And usually, nowadays, people are fixing this just putting code inside your business logic. So for example, if you're in the Java ecosystem, now you're using Istio, right? Or there is also, that for JavaScript, there is another library and so on and so far. So at the very end, when you want to do a resilient system, you end up not just coding your business logic, but also adding these concerns that should be something to be fixed by the infrastructure, right? Not by your code. And this is exactly what Istio and Service Mesh does. A service mesh is a dedicated infrastructure layer, right, for making service-to-service communication safe, fast, and reliable. And at the very end, you can think that Istio is a service mesh, and probably this is going to be, the winning solution, or it seems that it's going to be. There are other solutions, but now it seems that everyone is moving to Istio. And with Istio, we just can end up to fix all the problems that we have if we are not using a service mesh or Istio. Then let me show now more or less how a service mesh works. We have a service, needs to go to the network, and then what we are just doing is adding a proxy there that implements all these cross-cutting concerns. For example, how to discover a service, how to communicate with the service, or how to implement, for example, a circuit breaker pattern. And we put it in the proxy. Then what we really have is like something like this. We have a proxy, and the proxy is always is the one who's responsible of communicating between services. So we have a proxy that is responsible to communicate with service A, and then the service A have a proxy, and this as well that this proxy, when service A wants to communicate with service B, then just use the proxy, and this proxy communicates with the proxy of service B. Never there is a direct communication between services. There is always the proxy involved. And this proxy is the one who implements all these cross-cutting concerns. Before going exactly off what is, or checking Istio, let me introduce you Envoy. And really quickly, Envoy is a service proxy that's high parallel and non-blocking. Implements filters in level 3 and level 4 of the network stack. Also, out of the box, level 7 applications, was with HTTP, HTTP2, and gRPC. Baked in service discovery and health checking. This means that this proxy also knows who's going to, which service is serving, and then can check if this service is up and running periodically. It contains some advanced load balancing techniques, like, for example, circuit breaking, rate limiting, traffic shifting, shadowing. And, for example, also you can do things like canary release or blue-green deployments. We're going to see this in the demo. Also, it implements some stats, metrics, and tracing. So since all the network goes through the proxy, they can store this kind of information. And finally, Envoy is not like a network proxy, which you configure a file, you put this file in the COM directory, and then you boot up the proxy, and if you want to need some changes, then you need to stop the proxy and start it again with the changes. This, you can configure it dynamically. So more explicitly, what we have is like something like this. We have all our services, and we have a proxy called Envoy in all the services. So instead of being a proxy, in reality, it's an Envoy. So when I said when I said, look, this is the Envoy, what I mean is this proxy, because at the end, this proxy is an Envoy instance. The problem is that, okay, here is like 3 services, and there is only 4 Envoys, but what's happening if I have hundreds of services? These hundreds of services will contain hundreds of Envoy proxies, and probably I want to configure all these Envoy proxies. And what I need to do is just doing SSH to each of the machines and start configuring all the Envoy proxies. Obviously not, and this is exactly what Istio does. Istio means sail and provides a fleet configuration for all these Envoy proxies. So basically what Istio does is just abstracting you from having to configure manually each of these proxies. It implements a routing and load balancing control, implements observability. This is like this, what I showed before, that is like tracing, monitoring, and logging. This is what is called observability, then implements these things. It can be used also for chaos testing. And finally, it contains some security options. And these security options, we're going to see it now in the schema, but basically it means that it provides you a key management system to automate key and certificate generation, distribution, rotation, revocation. So now you can just secure your services without having to take into consideration what to do with the certificates, the keys, how you distribute it, how you revoke it, exactly. All these kind of things. You don't need to do it by your own. It's done automatically by Istio. This is Istio architecture, where, as I said, I have service A and service B, and all the communication between services goes through the Envoy or the proxy. Then we have the data plane, which at the end is the Envoy deployed as sidecars. When you say that a pod have more than one container, and this container has the same life cycle exactly of the other container, then it's called that it's like a sidecar pattern, because it's like a sidecar. And the when we said data plane, it's this proxy. Then we have the control plane, which is that plane, which is the bottom one, yeah, which is like how you manage and configure proxies to route traffic. So as I said, you need to configure all the proxies. So this is the entry point. Then we have the Istio pilot, which is for configuring all the data inside the proxy. We have the mixer, which the mixer basically enforces access control and uses policies across the services. So you can say things like service A can only communicate with service B, but not with C. For example, this is for things like that. Or it cannot only consume this amount of bandwidth. And also, it collects the telemetry. So as I said, Istio has the observability pattern implemented, so you can just, that all this data is captured from all the envoys proxies to Mixer, and then Mixer publish to your monitoring system. By default, Istio comes with Prometheus and Grafana, but you can use any other one. And finally, we have the Citadel, which is the last part, which is the one who provides all these key generation, rotation of the keys, managing the certificates, etc. I mean, that this is something that Citadel does. It's like for security and mutual TLS. Then the components that we have in Istio, that this is the types that we have inside Istio. We have a destination rule. A destination rule, basically, it configures a set of rules to be applied when forwarding traffic to the service, and these rules can be a circuit breaker, load balancers, TLS settings, and even defining a subset. And you will see that basically defining a subset, it means that you can take definitions by label. For example, you can say, I want to group all my Kubernetes services that has a label called V1, right? And this is a subset. And then I can have another one which is called V2, and this is another subset. And then you can reference to this subset in other elements of Istio. Then we have the virtual service, which basically a virtual service describes the mapping between one or more user addressable destinations to the actual destination inside the mesh. Basically, this is so complicated, I know, but you need to think about it like, describes the mapping between services. You said that I want to send 90% of the traffic to service A, V1, and 10% of traffic to service A, V2, for example. And as I said, it's a virtual service. It means that there is no registry. It's totally virtual. It's something that it's built at top of Istio. And finally, we have the service entry. By default, Istio doesn't allow your traffic to go out of the mesh. You cannot communicate to any site by default. It just gets you a timeout error. So what you need to do is just you use service entry, which at the end is egress. You define egress rules where you define how you can, or basically you instruct the mesh to say, look, if someone from inside the mesh wants to communicate to google.com, then let them go out. But if not, if it tries to go to another host, then just block the communication. You do things like that. And then we have the gateway, which is a load balancer at the edge of the mesh. So it's like, basically it's usually used for getting out the traffic that comes from outside to put it inside the mesh. And this is the relationship. We see that we have the network, right? Then we have the gateway where you said, when someone is trying to go to monolith.foo.com import 443, and I want to use TLS with this search, then allow them to go inside the mesh, and then we have the service, and then at the bottom we have the service X. Service X wants to communicate to service I. Notice that service X is monolith.foo.com, so in this case, the communication will be correct, and the gateway will redirect traffic to the service X. And then we said that in service X, there is a virtual service which we want to communicate with a subset called V1, which we are saying that when I'm in the service X and service X wants to communicate with service I, then always go to V1. Just forget to communicate with V2. Then there is the destination rule. As I said, the destination rule, then it defines that the circuit breaker things, for example, circuit breaker things and retries. Well, actually, retries goes to the virtual service. But as we can understand, is like how I configure that what's happening if service X tries to communicate with service I and service I is not up and running, for example. What I can do, I can do some kind of retrace or just open the circuit to avoid any of this kind of communication. This is done by the destination rule. And when it passes everything, then the service I is accessed. Then, just 2 or 3 things before going to the demo. We have in Istio, it's really easy to do, for example, traffic splitting. Traffic splitting is just, as I said, for example, canary release is a way of doing it, where you have service A with 3 pods. And then what I said add is a new service B, which is called canary. And then I can set something like all the traffic that goes from service A to service B, the 90%, 95% of the traffic goes to all the pods for service 1, or in this case is called current version, and then the 5% goes to the canary version. So it's really easy to do these kind of things with Istio. Of course, we can do better, and we can do things like content-based traffic. Instead of saying, I want to send the 90% of the traffic here and 5% there, you can say something like, I want to check the user agent header from the communication and said, if the header is Android, then move to these pods. And if the user is iPhone, then go to this other pod. Of course, this is, I don't know if it's really useful at all, having this kind of user agent, if it's Android or not, but probably it's a technique that you can use for dark launches. And you can do things like, if the IP is an internal IP of my company, then go to this new version. And if it's not, if it's a public IP, then go to the old version. So in this way, your own employees can test your service without your, let's say, public users notice it. So let's see all these, some examples of Istio. Okay, then let's just start. I have here an application which is like customer preference reference, right? And then I have two versions of a recommendation, which is V1 and V2. If I do here a call, then you can see that now I'm going to customer, then preference, then recommendation V2, and I do another call, then I go to V1, and I do a call and do a V2, and if I do again, you go to V1. This is because by default, if you don't specify anything, initially you use a round-robin approach, which is like, you know, iterating over all the instances. In this case, I'm going to V1 and V2. Now, what's happening if I want to send all the traffic to V1? The first thing that I need to create is a subset to identify what is V1 and what is V2. And this is basically done with istio-ctl create -f. You will notice that at the end with Istio, everything is a file. And it's a destination rule which says that I have V1 and V2. Okay, now I created this destination rule. I can, if you want, I can show you this destination rule. I noticed that it's more or less simple. Where I said I have the host recommendation, and I want to create two groups. One called version V1, which will be all these recommendation pods that contains a label with a key version and value V1, and the same for V2. There is no, I mean, there's no secret at all. The next thing is like, okay, now I want to redirect all my traffic to V1. What I need to do is create a virtual service to set, move all the traffic from preferences to the version V1. So I can do Istio files, virtual service, and I have several of them. And if I go in this one, I can do as well the Istio file, destination file, recommendation V1. Notice that what I'm saying here is that I have one, well, in this case I have two subsets, but this is destination rule. Wait, it's virtual service now. What I'm saying is that when someone wants to access to the recommendation host, just send the 100% of the traffic to the one which is the subset of version V1. So now if I start doing calls, you'll see that I always go to the version V1. And the nice thing here is that you notice that I have not recompiled anything. I'm not just going to my configuration file and say, no, go to V1 or V2 or nothing. I mean that my services are there running, and it's Istio who is taking care of all these cross-cutting concerns. Then you said, okay, now I want to send all the traffic to V2. Now I need to do a replace because I already have a virtual service. So if I try to create a virtual service when there are already one with the same name there, then yeah, I need to change it. So I need to replace it. So I go to virtual service V2, which is here. And then if I start doing the call, you see that I always go to V2. So I've implemented a blue-green deployment strategy without doing anything on my services, or or redeploying nothing. Then let's see, for example, if we want to do a canary, I need to do just, for example, istio-ctl replace -f istio files, and now in these istio files I have here, for example, 75% to v1 and 25% to v2. And then I can start doing calls, and then you see that there is a lot of v1s, and now I have appeared some v2s, but another again v1s, v2s. I mean that at the end I've implemented just a canary release with just doing or applying an Istio source. We can check. Sorry, this, and you'll see that there is no secret. The only thing that I'm doing is just saying, when I want to go to the recommendation service, please send the 75% of the traffic to version v1 and the 25% of the traffic going to v2. I just done this, and that's all. Now let me show another example. Now I'm going to delete this virtual service recommendation. And now again, if I do the call, I get it v1, v2, v1, v2, v1, v2, because I've deleted the virtual service. And now let me show you how to do shadowing traffic. Everyone knows what is our mirroring. Everyone knows the concept of mirroring shadowing traffic. Basically, the concept is that I have two versions, and I have a request, and I send the request to both services. But only one service, the response is the valid one. The other one is just, is ignored. So it's like a way to test that your new service works as expected without your end user notice it. So how to do this? Well, let me just first of all configure it's with a virtual service again, which is called v1 mirror v2, right? Now I have applied, I can show you again this file. And notice that now I'm saying that all the traffic that needs to go to recommendation goes to version 1, but please add me a mirror to version v2. Now, let me show you this thing, which is quite interesting now, because I do kubectl logs. Okay, this is the current logs. Okay, you see that the number is that 17, right? This is the logs of the version v2 of recommendation, and notice that the last one is the 17. Then what I do is just close this, and then I'm going to do a call. Notice what I'm getting, the v1, right? I'm not getting the v2. So in theory, you said, okay, v2 has not received the request, right? But now notice that if I do the logs, you see that there is at 18. So the request has gone to the v2, but the response has just been ignored. So in this way, okay, this is a really simple example, but if, for example, we see that we have Prometheus installed, then we can monitor a service when it's deployed in production but not released. So you can check if there is errors or not, and if there are no errors, then you can start thinking about doing a canary or a blue-green deployment. This is a really good way to know what's happening with your service before getting that all your users reach it. Yeah, I guess that for this is enough. Let me delete the virtual service. Okay, now we have again this call with v1, v2, v1, v2, and now let's see circuit breaker. Right now, let's think about that we have a service that it's receiving a lot of requests, a lot of them, and it's behaving really, really slow. Well, the thing that you want is that no more requests can go inside this service until you get it. So when this service processes all the remaining requests, and then after this time, maybe it's 15 seconds, then you want to say, okay, then now after 15 seconds, send again the traffic there, because I know that it had a lot of work to be done. In this case, of course, I don't have a way to simulate this, but what I'm going to do is going to recommendation vertex, then I think that here, and what I have here is like adding a sleep of 3 seconds, okay? Let's, I mean, I know that it's not so clean, but you just need to think that this is just simulating heavy load. Then I can save, and then I'm going to deploy this service in the poor boy solution. Don't do this at home, but yeah, for now it's enough. I'm just creating the jar file. Then I'm creating the Docker build, and I create the Docker image of v2. And finally, this is really fun. I do a kubectl delete recommendation version v2. Okay, and now what I'm just doing is rebooting the pod with the new version that I've deployed. See that, and now this also helped me to see that here in, for example, recommendation, you see that there is 2.2 because there is 2 containers. Remember that there is my service and also there is the proxy container, Envoy container that are running. For this reason, there are 2.2 because there are two containers and both are ready. Now I have this up and running. I can go here again, and now if I do the call, when I go to v1, it goes pretty fast. When I go to the v2, yeah, it takes 3 seconds, right? So as I said, that's pretty nice, but well, and now I can even, if you want, I can simulate. In this case, I'm simulating that using 2 threads launching 20 requests, and you see that when it goes to v1, it goes pretty fast, but when I go to v2, it goes pretty slow, 3 seconds. But you will see that every time there's here, you can see that there is 6 seconds because all the requests are being, queued, and you still need more and more and more work until you arrive, for example, in 9 seconds, right? As I said, imagine that this is like this service is receiving a lot of requests. You don't want to just produce like, okay, stop sending more requests to this service, at least for, I don't know, 10 seconds or whatever. So how you can do this in Istio is like using a circuit breaker, and you just need to do a ctl create Istio files. This is a circuit breaker, so it means that I need to replace a destination rule because the circuit breakers are defined in the circuit and in the destination rule. And now I have mine, which is like this one. I guess that this is this one. Sorry? Yeah. Yeah, I show it. Yeah, wait. I think that it's this one, yes. Now I'm going to show the file. Let me finish this. And now I'm going to create a new virtual service, which basically sends 50% to request to v1 and 50 to v2. Okay. Now you want to see this file, which is like destination rule. This one, right? Actually, this should be this one. Which basically you are defining that with v1 you don't want to apply any circuit breaker pattern, but in the v1 you want to create a new circuit breaker where you only allow 1 request. Of course, in theory, in production, you will do like 100 requests or whatever, but I put it 1 because it's easy to show. And then there is this base ejection time and max ejection person. Well, the interval is consecutive. Well, I mean that this is, you can see in the documentation, but the max ejection person is how many pods you want to eject when this is happening. And you said that always. And for example, you're saying here consecutive errors when you want to open the circuit. And you said in the first problem, just open the circuit. It just, as I said, for this demo purposes. Then let me just replace, because I think that I've applied one that it's not the, or yeah, I know. I need to put it this, okay? Yeah. That is that I only want circuit breaker for v2. Now, if I do siege, notice that it goes pretty fast, right? But notice how many errors. What's happening here is the next thing. This is all the v1s. That works pretty well. And then this is V2. In V2, since there are only one consecutive, I only want to add one connection, if not, then fail, I just return 503. So what I'm saying is like, look, my service B, my service B V2 has heavy load, so just open the circuit and does not allow more connections from service A to service B. For this reason, I'm getting all this 503. Again, notice that I've not recompiled my service. That I just applied these files and just works. Okay, now let me, that this is one thing of circuit breaker. Now I've deleted all the destination rows and virtual service that I've created just to have everything clean. And now let me introduce you the concept of pull ejection. Pull ejection is a concept which means that when Istio detects that there is a pod that is behaving incorrectly, it just removes this pod from the pool of possible pods that can serve a request. And it adds this pod again after some time. So it's a way to just avoid getting failures to your users. So let me do -ctl create -f Istio files. Let's start with V1, V2. And now let me also start with Istio files, destination, virtual service, V1, V2, which is here. So now, again, if I do the call, you have V1, and then when it's V2, then it goes pretty slow. Now, let me do kubectl scale. Okay, now I'm going to scale to have 2 instances of version 2. So now you have to do kubectl get pods. Now you see here that I'm running this V2, and then I'm starting another V2. This will take some time. Now I'm just scaling to have more instances. Meanwhile, I can change, because I'm going to put it that the virtual service is not, I want to force that it's 50-50 because, because now what we're going to have is like 2 instances of V2. So I want to have V1, one instance of V2, V1, the other instance of V2, not just, twice V2 and one V1. Now if this is deployed, now I can do a call, and now you see that now I'm getting V2 because it's an asleep, and notice the number, which is 82. I do the same, now it's V1, and now I do again a V2, which this V2, you see that this is another pod, which is the RLC, right? That there is, I'm just going from V1 and V2, and you see the sleep. But now let's force an error in one of these pods. Suppose that you have there is some errors there for any reason. Suppose that this pod cannot connect to its to the database, so it's getting some errors. Again, I cannot force this in a better way than just going inside this this pod. Now I'm inside the pod. I'm going to do a call to HTTP localhost 8080/misbehave. And now notice that I'm saying that this pod instance is going to return all the time a 503. Then I can do an exit, and then of course I can do a call. And this is the one. Now I'm getting a 503. I can do a call, and now probably I'm going to get the real answer. That V2, but the instance that it's working correctly. And then if I do again, now I'm getting now 503, and now a V1, right? So that it depends of the user that will get an error or not. Let's apply. Circuit breaker here. Istio files destination rule, which is pull ejection, which I'm saying, as I said, this pull ejection thing, which is this one, which basically, well, you can see that there is a lot of things, but the important is this one, which I'm saying that when a user goes to version v2, just if there is one error, and just the base ejection time is the time that I need to wait until the failing pod are available again. So basically, it's like if the pod returns an error, then just remove this pod from the pool of eligible pods during 15 seconds. So now if I do, for example, again, the curls, you'll see that the error is happened just once. I don't know if this instance is going to fail. Yeah, now you see the 503, and then all the next time that I'm going to do this, you will see no error until it happens these 15 seconds. Notice that now there is no errors. It's the V1 and the V2. The V2 happening twice, and all the time the V2 is the instance that it's working correctly. And now, after some time, you will see again the 503. And notice that I get this behavior without touching my code. My code is still the same. It's developed there, but I'm changing how everything works. And now you'll say, oh, wow, that's great, right? But there is still one user that have received the error. You said, oh, but there is an error that will receive the error, then this pod will go out, and then it will wait for 15 seconds, and then if the pod still behaves incorrectly, the next user will get this error, and so on and so forth. So what we can do is just automatic retrace. And retrace is something that goes to virtual service. And what I'm going to do here is something like, this one? Yeah. What I'm going to do here is just saying, if the communication between service A and service B fails, retry, right? And now, if I do a call, you will see that never you will see a 503 error. Never. You can wait there, and you will see always that it's working. Why? Because the request that goes to the service that now it's failing, it will just fail. There will be a pull ejection. It will return saying, hey, this request has failed, and then Istio will say, okay, then I'm going to do a retray. Since the retray will go to the pod, but the pod that is failing is ejected, it's not there, then it will be served by a pod that is working. And then the request will be the response will be the correct one. So in this way, none of your users will ever notice that you have some failing pods there. Finally, let me open this, and I can go to, I don't know if, yeah, I can go here. But this is not, I mean, this is OpenShift, but at the end it's Kubernetes, so it's exactly the same. You'll see. Now, what I'm looking, sorry, it's this thing. You'll see that by default, I mean, that they've installed Istio. I've not done any custom things. And by default, I have, for example, Grafana installed. And here you can see all my, for example, the Istio workload dashboard, which now it's getting nothing because I need to do some curls, I guess. Well, now it's the data slip thingy. Okay. Let me see if I check here. Istio Service. Now, well, now I'm doing this. Okay, let's. Now, I mean that there is. While this is refreshed, someday we will see here some data. Okay, for now I leave it. I mean, well, let me see that. Then they will appear. Then we have here a Prometheus. Then there is also okay. Then there is also the Prometheus, which is the one who collects all the data, and Grafana is the one who shows all the data. Someday it will work, no worries. Let me, if you want, I can try to find. Yes, this service, of course. And finally, let me show them. Now it will work, no worries. Probably when I finish the demo, then it will appear everything. Now let me introduce you a new tool which is called Kiali, and Kiali allows you to, see what's happening inside your mesh. See here that I have customer v1, preference v1, and here we have the recommendation v1 and v2. Notice that there is green, it means that it's working. And now you have here some schemas. If I check to the V1, it says here that has circuit breaker. I know that probably you're not saying this, but no. So you can see the number of requests that works or not. And then I have here V2. And in V2, you'll see that also there is a circuit breaker. And if I check recommendation, you see that recommendation has a virtual service and with the success rate and so on so far. And then if I check, for example, V1, you see here all the pods that are running here in the V1, and you have inbound metrics and output metrics. Well, it doesn't matter this thing. But if I go here, and you said, yeah, but I want to see how it's configured. I know that there is a place that I checked it yesterday. Let me check here. Yeah, you see that there is a service recommendation with the workload that is healthy. If I check here, there is a place where I can see, well, there is the 2 versions. And I think that I'm navigating around. But there is a place where you can see the code. I don't remember where is this. That you see that which is the what you have configured as circuit breaker. But now I cannot find it. Wait, let me. No. I know that that exists. Well, meanwhile, look, this is a problem of healthy. Okay. Well, meanwhile, this tries to work. All right. Now there is also the here the Istio tracing, which basically uses Jigger to get how all the requests has gone. You can go to customer, and then you will to find all the traces of customer, and you see that today, 29 minutes ago, I've done a request that took 9 seconds to be served, and it spends sometimes in preference, this in recommendation, and this is all the information that I've used. So this is regarding tracing. And all this information are there free for you if you are using Istio. And now that I'm here, I don't know why. Error rate degraded, okay. I'm trying to find this, maybe here. Okay, never mind. I know that there is somewhere one option where you can see all the, this is traces. Okay, there is this is why I cannot see the traces. Okay, you put the traces and then you navigate directly here. I know that there is an option somewhere where you can just, in Kiali, where you can just check what's happening. And now finally, it's not showing anything. Okay. Refresh, live. Okay. Oh, no, I don't want to be there. Then, let's wind down. First of all, I know that probably most of you said, this is really cool, Istio. I can redirect traffic, I can do canary releases, I can do blue-in deployments, I can do mirroring traffic, circuit breakers, and I can make my services resilient without, having to implement it in my business logic. But please, before you start using Istio, use this digital Darwinism, which is something that is coined by Álex Soto, and it says that that everyone knows Darwin, right? That it was not like one day we start working by 2 legs, right? The bipedism didn't start like this. That previously, in several thousands of years, we start preparing the bones, the brain, and so on and so forth. And this is exactly the same. If you want to do these kind of things that are really cool, just do it. But first, reorg your organization to DevOps, then start doing the self-service on-demand elastic infrastructure as code, which basically means that if you need a database and you need a virtual machine with your database, and you need to open a ticket, wait for 3 days, and then say, after 3 days I have my SQL database that I needed in this virtual machine, which it's running on the production-like environment, then you need to change that. This should be seconds. In 10 seconds, you should have your database up and running on a production-like environment. And this is why Kubernetes and OpenShift really fixes this problem. Automation, you need to do everything in an automatic way. CI/CD deployment, and CI/CD deployment doesn't mean that you have a Jenkins. It means that you commit to trunk and through a trunk or master branch, and all the time anyone can say, okay, let's deploy master branch, and it should work. If not, you're not doing CI/CD. Having just Jenkins running there, and and you're putting some kind of ignoring test, and there is a red bullet there, and you're ignoring, and this kind of thing, this is not CI/CD. Advanced deployment techniques. Of course, you can start using Istio, but if you want to, that probably you would like to do this kind of canary releases, mirroring traffic, or even blurring deployments. But just take into consideration this and get it how you are going to implement it, and then finally you can use Istio in your microservices, but not on the other way. It's not like, okay, I'm just having 50% of all these kind of things, then I'm going to start using Istio. No, because that probably you're going to fail. Of course, you've seen here me saying Istio-CTL, blah, 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 right, manually, but of course you need to do it manually, automatic in your, for example, in your Jenkins file. Even there is, there is a Istio library in Java, so you can interact with Istio programmatically in Java. So if you are using Jenkins and you're having your Jenkins file, then since it's Java, you can create your own plugin for Jenkins file to do all these kind of operations, not in saying shell, Istio-CTL, blah, 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 but in a fashion way. And yeah, I know that it's something really new, but the change is the essential process of all the existence. So that probably most of us were thinking, I would like to do it this, but I work in a bank, so I'm sure that I'm not going to be able to do it. But at the end, it's like the change, right? I know that some banks are changing. Big enterprises are moving to Istio. That in Red Hat, several clients, which are like insurance companies, are moving to OpenShift and Istio. So it means that it's not totally lost, right? Any question? No.
Okay, first of all, disclaimer, I'm not at all knowledgeable on Istio, so please excuse me if I say something foolish. But getting back to your circuit breaker pattern and that ejection time, I was curious if there is a way to define a health check in the proxy, and so the proxy keeps the state of the health check, and based on that health check, if the backends pass the health check or not, will circuit break them or not?
Yeah, well, the health check, it goes by the liveness proof and readiness proof of Kubernetes. So it's managed by this. So you define it there, and this is something that I'm not totally sure that you can. You mean that you open the circuit without receiving requests, right? Something automatically. I'm not sure that this is possible. I'm not 100% sure, but I think that it's not possible. Okay. But that I never asked, or I never implemented, even I never asked myself. But it just is like, this is my Twitter and my email. I put it the mail, and sometimes people ask me, can I send you an email? Yes, of course. I put it there the mail because you can send me an email. If not, I will not put it. And then if you are really interested in this, send me an email or send me a tweet. Hey, I'm the guy there. Can you? And I will ask. Or I can find myself, or even, for example, in Red Hat, there is Christian Posta, which wrote this book, and he's also in the Istio committee. So if I cannot find the answer on my own, or you cannot find it, I can ask him if it's possible or not.
Okay, thank you.
You're welcome.
I'm a software developer, so I'm not a sysadmin guy, but I'm interested in the matter. And I would like to know if it's always needed with Kubernetes to use Istio. Do you recommend, or you can use only Kubernetes without it? And also, if when you have it using it, all the pods need to be with your application with two containers always in each pod, with one with the application and the other with the.
If you want to stay inside the mesh, yes.
Okay.
But you can have pods without Istio, because this is, I have not show. I can show you in a moment. to make that your pod is istioized, there are two ways. I like to use this one. Let me wait. Now I'll do the completion. Wait, I've done this morning, so I do a history and I guess. You need to do this. You need to do this thing. Okay? You need to do this thing. You need to do kubectl apply, as you usually do, and then your deployment file is exactly the same as you will have in Kubernetes. There is nothing related with Istio. It's your deployment file. You can use it in your Kubernetes. But then what you do is like doing this, istioctl kube inject. And what it does this is just taking your deployment YAML, okay, and added all the information related to the envoy. I mean that I can do, for example, kubectl get pods .yaml, and notice here that you see that you have this container proxy v2 100 and all this stuff. Okay, and here is my real image. So this inject it takes my YAML file and let's say add these things. So you can have your pods with proxy and your pods without proxy. But if you're outside the mesh, then remember to do a service entry, an egress, to communicate the pod from inside the mesh with the pod outside the mesh. If not, there will be no possible to communicate. And the other question was...
if you think of any case...
using Istio in Kubernetes, we said that, yes. I mean that because at the very end... Well, I mean, at the very end, you still need a circuit breaker, right? So you can implement it on your code and maintain it there. In case of Java, you will have some problems with a class path. Then also, if you are in a polyglot, you will need to use one library for JavaScript, another one for Go, another one for Java, blah, 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 and you need to learn all of them. In this way, no, you just learn one, and it works. So, I would say yes, use Istio. I mean that if you're in Kubernetes and you have, of course, if you have, for example, I'm using Kubernetes, but I'm using the microlith approach with, 4 instances, then I would say, well, maybe it's not necessary for 4 services which are microlith and so on. Well, maybe it's not, but and at the same time, maybe it's the opportunity you have to learn Istio in production in an easy way, not with hundreds of services, right? I mean, that this is something you need to check. But yes, I mean, I would say that if you're using Kubernetes and you have like these tens of services, then yes, use Istio.
Okay, thank you and congratulations.
You're welcome. Thank you.
Real quick, because we're out of time, please.
Hello, thanks for the talk. Can you put some examples of chaos testing aside what you have?
Chaos testing, yeah.
Yeah.
Chaos testing goes, wait, because now I'm trying to remember where I put it. Wait, no. Wait, because now I don't know why I see it in this way. The files. Chaos testing was, I don't remember the name now, but there should be one. This is the egress example. Here, timeout. Just here, what I'm putting is that when I go to the host recommendation, just add me a timeout of 1 second. Then there is another. I have a delay. Delay, I think that it's more. This is for making it fail here. What I'm saying here is like when I go to the recommendation host, add me a fault when I go through HTTP project where the 50% of the traffic, just add me a delay of 7 seconds. And there is also, you can also set, for example, return me this error code and so on and so forth. Yeah, you can do things like that. In fact, I mean that if you, I mean that this is not, it's something that it's public. And if you go to, to Red Hat developers demos, I mean that, Red Hat developers demos Istio tutorial, or you find in the Google Istio tutorial, then you see here that there is this one, which is with Antora, and you see some of the things that I showed, plus you see here that I said fault injection, and you see here the how to, for example, generate 503 errors. In this case, we can check it if you want. We can do this. And now I'm saying that just add me a fault in the 50% of the traffic with aborting the communication with the 503. I mean, it's not. I mean that it's not super complete, right? The feature that allows you for chaos testing, but allows you to do some things that well. It's. I mean, I think it's taking into consideration that nobody does chaos testing. If you are doing just the chaos testing that allows you Istio, I think that it's well enough. Yeah. I mean, I will be here. I mean, well, if you now there is coffee time, so if you have more questions, you can ask me. If you need a coffee, then yeah, it's fine. Thank you.